Homework 3.5, Rational Functions, Video 9. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. Following video correlates to questions 17 through 21 on your homework. In the previous video, we graphed a rational function by going through these 7 steps, and in fact, I think the homework actually calls it. Let me make sure I'm right. Follow the 7-step strategy. Ooh. I call it get all the information we can to draw the graph. All right, so suppose f of x equals 3x over x squared minus 16. We're going to run the same course as before, starting with the symmetry. To check for symmetry, in other words, to check to see if the function is even or odd, you start by putting a negative x everywhere there's an x. But let's be efficient about it. If I put negative x on the top, 3 times negative x is negative 3x. And if I put a negative x on the bottom, the negative gets squared and goes away. So it stays x squared minus 16. Basically, even powers stay the same, odd powers change signs. Now, is this the original function? No, it almost is, except for that negative. Except for that negative. Wait, if we pull the negative off in front, we do get the original function. We get the negative of the original function. F of negative x equals negative f of x is the definition of an odd function. And an odd function has origin symmetry. And remember what that means. That the right half of the graph can be rotated 180 degrees to get the left half. We can use that as a graphing aid or to make sure that our graph looks good at the end. Y-intercept, let's put in 0. F of 0 is 3 times 0 is 0. 0 squared minus 16 is negative 16. 0 divided by negative 16 is 0. So we have a y-intercept at y equals 0. Let's find the x-intercepts. Well, we just put this equal to 0 and solve it. But let's think about this for a second. When we did it the last time, we multiplied both sides by the denominator, which killed the denominator and left the 0 alone. So essentially, we wound up with the top equal to 0. So here's a little FYI. To find the x-intercept of a rational function, focus on the top being equal to 0. And what makes the top of this equal to 0? 0. So x equals 0 is the only x-intercept. It's the only number that makes the top equal to 0. Vertical asymptotes? Well, what makes the bottom equal to 0? What makes x squared minus 16 equal to 0? We have ways of solving that. You could solve it by factoring, or you could add 16 to both sides and take the square root of both sides. But if you do, don't forget the plus minus. Both of those numbers make the bottom equal to 0. Neither make the top equal to 0, so we have 2 vertical asymptotes, one at 4, one at negative 4. I think in the homework you have to list them separately. Read the directions closely and it will tell you. Horizontal asymptote, compare degrees. The degrees do not match. The degree in the denominator is greater. And when the degree in the denominator is greater, the horizontal asymptote is y equals 0. If it were the numerator, there would be no horizontal asymptote. Before we go digging up extra points, and again in the homework, they will tell you what extra points to dig up. Let's graph what we know so far. We know there's a y-intercept and an x-intercept, both at 0, and those are the only intercepts. We know there are vertical asymptotes at 4 and negative 4. We know there's a horizontal asymptote at y equals 0. That's the equation of the x-axis. Okay, we don't have a lot to go on here. We need more details. We need more evidence. So where do we find evidence? We look around the x values that we already know about. I know what happens at x equals negative 4. I know what happens at x equals 0, intercept. I know what happens at x equals positive 4. I need more evidence. Now this time I'm going to dig up a little bit more evidence. I'd like to pick a couple of points to the left of negative 4. So let's go to -6 and -5. Let's pick one point between -4 and 0. How about -2? And let's pick another point between 0 and 4. How about 2? And let's pick a couple of points to the right of 4, 5, and 6. Wait a minute, I don't have to do all 6 of these, I can only do 3 of them. Why? Because we know that putting in a negative is the opposite of putting in a positive. In other words, whatever we get here will be the opposite of what we get there, and here, and here. So I really only have to do both of these if I take advantage of the fact that it's an odd function. So which of these do I want to use? Let's do the positives. Starting with 2. If I put 2 in the top, I get 6. If I put 2 in the bottom, I get 4 minus 16, which is -12. That reduces to -1/2. But because this is an odd function, opposite inputs give opposite outputs, which means if I put in -2, I'll get +1/2. That makes sense, because we would just lose we get an extra negative sign up there. Let's clean this up. 1/2, -1/2. Okay, let's put in 5. When I put in 5, on the top I get 15. 3 times 5. And on the bottom I get 25 minus 16, which is 9. That will reduce by 3 and give us 5/3. And because it's an odd function, opposite inputs give opposite outputs. So -5/3 here. And if we put in 6, we'll get 18 on top. And 6 squared is 36 minus 16 is 20. Yep, 18 divided by 20, that will reduce by 2 and give us 9/10. These aren't very big outputs. And because the function is odd, opposite inputs give opposite outputs. Okay, my outputs are very small, but I think they're going to get the job done. Think in terms of decimals if you must. This is -0.9. This is -1.7 if you round it off. This is 0.5. This is -0.5. This is 1.7, and this is 0.9. All of these decimals could easily be obtained with a calculator if necessary. All right, let's plot the evidence. -6 and down almost 1. So -6 and down almost 1. -5 down 1.7, which is closer to -2 than -1. So over 5 down 1.7. Because of the horizontal and vertical asymptotes, I'm confident to draw this branch of the graph. If you're not, get more evidence, more dots. In the middle, don't forget we got this intercept. At -2, we go up 1/2, so not up very much. But at +2, we go down 1/2. And I must connect these dots and either go up or down as you get close to the vertical asymptotes. So when I connect these, will it continue to go up or will it turn around and go down? It can't turn around. There's not another X-intercept across. It must continue going up. Same thing over here, and now I can capitalize on the origin symmetry. I just rotate this, get the bottom half, and speaking of origin symmetry, these 2 points, 5, 1.7 about here, 6.9 about there. Those are just the rotational images of those points. I can rotate this whole branch over here. I knew that was going to happen because it was an odd function, and we're done. Now, if this were in class, I would have drawn this on the board where the overhead projector would put Desmos onto the screen, and I would have drawn it onto an empty Desmos graph, turned on the graph in Desmos, and have everybody go, ooh and ah, what you drew matches exactly what Desmos said. But I'm using the wrong board to do that. Okay, so we had 3x on top, and we had x squared minus 16. And we claimed that we had a horizontal asymptote at y equals 0. There it is. A vertical asymptote at x equals 4. and another one at x equals -4. Now I could turn on all the dotted lines and change the colors, but our asymptotes seem correct. And that looks a lot like what I drew. Yay me. All right, I got a couple more examples I want to show you because I would be lying if I said they all act the same. Some of them have other issues, as you're about to see.